Maintaining the temperature of the body, though, is going to be so much more than just 98.6. Because these chemical reactions, temperature affects the rate of a reaction. When molecules get heated up, they move faster. In the body, if temperature goes up, things are moving faster and they bump into each other, things get broken down. That's not always good. Okay? Now, if the temperatures go down, materials are not moving as quickly as they should be. That can have just as much of an effect as the temperature being too high and molecules busting into each other and breaking stuff up that don't need to be broke up. Okay? The concentration is important. The higher the concentration of a substance, the more the reaction increases. Now, the body, under certain circumstances, has a way to say enough's enough. You've given me enough of this particular element, enough of this particular product, whatever the case might be, I can't deal with any more of it. And it'll send the excess into waste. It'll either come out through the urine or through the feces. All right? So the body does have limits. A good example, concentration of reactants, oxygen. Oxygen. Is it the most important in the body? Mm-mm. What controls it? Any idea? We breathe it in, but we breathe out what?
CO2.
CO2 controls everything.
That's right, because the receptors in the blood pick up the CO2 and that causes to breathe.
Oxygen is inside that little red blood cell stuck to them little hemoglobins just riding around. CO2 is going to be what determines how much you need to inhale, exhale, blah, blah, blah. But wait a minute. Should I discount oxygen? Oh, no. No. Because what process in the cell uses oxygen? It's going to be part of that Krebs cycle for cellular respiration, which is making the ATPs. That's the only thing we're using the oxygen for. Now, in the process, we're giving off the CO2, okay, which when things are working nice and great, okay, hopefully, woohoo, moving back through the blood, coming back to the lungs, breathing it out, getting a balance, breathing it in, blah, 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 blah. Okay? But if your body's demanding or needs more oxygen, it's because of the CO2. If it says, okay, you don't need to breathe quite as hard, it's because of the CO2. The brain maintains its pH because of the CO2 in blood. I mean, is that just not the coolest thing ever? You know, you tend to think oxygen, 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 okay, when really CO2, CO2, CO2. Now, these reactions that occur in the body, a lot of times, the reactions that take place need a little bit of help, all right? So, we're going to have catalyst. What do you think of when you hear catalyst? I think of a control. I think of the one that's on my car, catalytic converter, okay? Because it's kind of like supposed to be converting some of the bad stuff, not be so bad, blah, 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 okay? So, catalyst in the body, for example, when we take in sugars usually whatever you've eaten is full of sugar, and the body needs to break it down quickly. Else, it sits in the intestine, sits in the digestive system, creates a bunch of gas. Woof! Okay? Methane. Y'all think about how that comes out. Okay? And we need that reaction to occur quicker. So, catalysts can come in. They're in the form of an enzyme. Enzyme is protein. Because the only thing the body can make is protein. All right? It'll come in, help to break down those sugars, get them broken down into their smaller parts so the body can either use it or store it. And in the hopes of all of that occurring, don't create that methane so that people walking behind you don't have to move. Just saying, you know. So, the amount of energy that's needed for these chemical reactions is your activation energy. And every reaction is going to have some type of activation energy that we need the enzymes to act as a catalyst to help get it started. If we can start the reaction faster, we get the products quicker, and the body can use them more efficiently. Otherwise, a lot of things would just kind of be stuck in limbo in the body. Not a pretty sight, right? Ever know somebody lactose intolerant? Anybody in here lactose intolerant? Okay. If I give you a whole bunch of dairy products, what's going to happen? You're going to build up that methane. Now, gets painful. Might have to go to the bathroom. Okay, got a lot of them little GI things that'll be going on in an area. All right. Why is it a problem? What do you lack that makes your body lactose intolerant? You lack an enzyme called lactase, which would be the catalyst that would help the body break down the lactose so all those things wouldn't happen. That's pretty cool. Just think. Take a break. Be back at 3:30.